Section 7.1, Parametric Equations. Definition. If x and y are continuous functions of t on the interval I, then the equations xt, or x equaling xt and y equaling yt, are called parametric equations. And t is called a parameter. The set of points xy obtained as t varies over the interval I is called the graph of the parametric equations. The graph of the parametric equations is called a parametric curve or a plane curve and is denoted by C. So what we're going to do here is we're going to deal with parametric equations now, which this is another way we can talk about rectangular equations. That's just with x's and y's. So what we can do is we can go back and forth with that, kind of like we did with the polar, like we went from polar to rectangular. We can go from parametric equations to just x's and y's in equations. We can also graph these, so we're going to kind of do the same thing we did with the polar equations. So here's our first one. So this one says sketch the curve. So here's our xt and yt. Oops, that's supposed to be a t. Okay, so what we're going to do with this is we're actually just going to graph it. So first things first, we're going to need a rectangular coordinate system, and we're going to need a XY table set up. So I was looking at the values t squared, so I figured we need a larger graph for this one. Now what I'm going to start doing is just filling in values for this XY table here. So the first thing I'm going to start with is 0. And when I plug in 0, that's really going to be this for x. X equals 0 squared plus 2 times 0, so that's going to be 0. Y is going to equal 0 plus 1, which equals, I was going to put 0, 1. So the way that works is I'm just taking this equation here for my y and just plugging in 0 for that t. And that's going to be 0 for my x and 1 for my y. Now what I'm going to do is I'm just going to continue this process. So I'm going to do a 1, 2, 3, 4, 5, 6, 7, 8, and 9. And one thing I kind of noticed before even graphing it, that this here was just a line kind of function. And this one was kind of a quadratic. So when I have a linear and quadratic together this way, it's going to give me a parabola. I mean, I can see that right away just from that. Just like we would have like an x squared equals y or a y squared equals x. And we're going to see what we end up with this one. So I'm just going to continue that and just hopefully get enough points to get a good picture. And actually we will. So not really hopeful, but we will. So I'm just going to finish this table. So there's our table. So now all I'm going to do is graph these, because these really are just ordered pairs. This is really 0, 1, 3, 2, 8, 3, 15, 4, 24, 5, and so on, all the way down. But these are some really high values, and my graph doesn't go that high. So I'm only going to graph a few of these. I'll graph up to here, so I'll graph all of those. So the first point is 0, 1, so that's going to be here. And then our next point is 3, 2, so that's going to be over 3 and up 1, so that'll be 2, so it'll be here. Okay, and then the next one's going to be 8, 3, so that'll be there. And then the last one we're going to do is 15, 4, so that's going to be here. Okay, now those are our first 4 points. That definitely does not look like a parabola yet. Honestly, looks kind of like a straight line, if you guys probably would think the same thing. So what I'm going to do is I'm just going to do some more values. So we need another table. So now I'm just going to start plugging in values for this one. So instead of going 1, 2, 3 like I did the other way, the one way, I'm going to go the other way. So I'm going to go -1, -2, and so on and so forth. So I'm going to finish this table. So now I'm just going to do the values for these and come up with what those should be. So for instance, when I plug a -1 in for my x, that's going to be a +1 for the first piece and plus a -2, so it's going to be a -1. And then for my y, when I plug in a -1 here, it's going to be 0. So there's my first one. Now I'm going to just fill in this table here. So now what we're going to do is we're just going to graph these. There's a lot of similarities here as I went through them. There's a lot of symmetry that we're going to see. Like, look at this last one here, 80, -9, 80, +9 here. So I'm just going to graph a few of these now. Like I said, my graph isn't big enough to graph all of these, but I can graph at least this many points here. So those are the ones I'm going to graph. Okay, so the next one is going to be -1, 0. So that's going to be there. And then it's going to be 0, -1, which is going to put me down there. And then the next one I'm going to graph is 3, -2. And then 8, -3. And the last point is going to be 15, -4. And we can see now that this is actually our parabola. And we've dealt with these kind of parabolas before, the sideways parabolas. We just went through a bunch of them. And take a look at what this graph is now. So if we follow it through, there's the first half. And then when I go -t's, actually that vertex there was a -t2. That's where my -t's kind of started at for us. So that's our graph there. So now what we're going to do next is we're going to take this graph here, this x, t, y, and t, and we're going to turn it into a rectangular graph or coordinate. What I mean by that, this is already rectangular coordinates. We're going to turn our x, t, and y, t into just an equation of x's and y's. So what I'm going to do this is I'm just going to take this second equation here and solve it for t. So I'm just going to call that y instead of yt. So if I subtract 1 from both sides, I actually get t equals y minus 1. So now I'm just going to take this here and sub it in the other one wherever I see t at. So that's what I'm going to do next. So that means my x is going to equal y minus 1 squared plus 2 times y minus 1. So like I said, I just took all of the t's and plugged in y minus 1. Now what I'm going to do is I'm just going to distribute and simplify. And that means for the first part here, so for this part here, this means that's going to be a FOIL. So it's going to be y minus 1 times y minus 1. So now in simplifying this more, I can take and put my y's together, my numbers together, and that's what I'm going to do next. And then finally, move my 1 over to the other side. Now notice here, I had a negative and a positive, so those actually cancel each other out. So then for the final step, I get y squared equals x plus 1. So if you think about this equation, and we've had this just in the previous section, that is going to give me a sideways parabola for sure. So I just kind of wanted to show you, once we converted into an x and y equation, that we would actually get what appears to be the same graph that we ended up with if we had to graph that equation. Okay, well there it is. And we didn't need to do this part, but I just wanted to kind of show that to you so you can see how it resembles the sideways parabola that we see.